Greetings, welcome to Self-Assessment 7, Problem 4, Part 1. We're going to break this problem into two parts. Spend a little time talking about the graph in this first part, and then in the second part we'll answer all the remaining questions. So we're asked to take a graph g of x equal to log base 3 of x on a graphing calculator with the given window settings, and draw what we see in the calculator screen below. So let's go ahead and do that. Let's get over to our calculator. So we're going to go into our y equals menu here. And some of these calculators will allow you to enter in directly. In other words, you can come back here. We can just put in log base 3 of x. But the generalized way that works on all of the calculators, even if you have an old dog 83, is to use the change of base theorem. So in other words, we'll convert that into common log. So we're going to go ahead and call that log of x divided by log of 3. Okay, by using the change of base theorem, we'll be able to get this thing to graph for us. Now, they did ask us to use a specific window settings, so we're not going to go use the standard ones. They asked us to go from 0 to 10. And then if we go back to the window settings on the y values, they just wanted us to go from -2 to 2. So the y min, they wanted us to go from -2, and the y max, they wanted us to go to a +2. Okay, let's go ahead and graph that. And we get the following logarithmic graph. Okay. Now, a couple interesting things. Just like an exponential, a stock logarithm, one that's not been shifted or translated in any way, shape, or form, is always going to go through the point 1, 0, just as a stock exponential always went through the point 0, 1. Remember that a logarithm undoes what an exponential did. They are inverse operations to each other. But let's talk about a few things about this graph and make a sketch of it back over here on our sketch sheet here. Okay, so first of all, they asked us to make a graph or a sketch of what we see on our calculator screen. So let's go ahead and put in an x-axis, excuse me, a y-axis. Hey, geez Louise, that's our vertical axis there. And then let's put in the x or the horizontal axis here. And then let's go ahead and label those. We'll put that that's the x, and then that's the y, and that we're going from 0 to 10 and from -2 to 2. That's always a good thing. You want to set up your axes just as they show up on your window. But I'm going to put in something additional here, something they didn't ask us for, and I'm going to put in the vertical asymptote. So the y-axis here is acting as a vertical asymptote. It means that the graph is not going to go beyond that. So this magenta line here is a vertical asymptote. And we'll, in an instant here, a short instant, go in and talk some more about this in part 2. But for the moment, I want to illustrate to you that that vertical line we know has got the equation x is equal to 0. So what that means is that the graph of this, the behavior of the graph is going to come up as close as you possibly could ever want it to get to the y-axis, but it's never going to touch it. So it comes up, passes through that point, and then it keeps on going. It's going off to positive infinity here. It's going to take off that away, and it's going to take off down this away, but it's never going to touch the y-axis. And as I stated a minute ago, that point right there, we saw that on the graph, that point is at 1, 0. Okay, so a common mistake that is made, and part of why I'm spending a little bit of extra time on this, is a common mistake is that you will see people draw graphs of logarithmic functions based upon what they see on their calculator, and they'll make them look something like that. They'll make them almost look like they're a square root graph. Or they'll make them look like they come down and they start right here at the y-axis. And that's just an artifact of the way that our calculator graphs it, but it's not representative of the actual behavior of the function. If this was log base 10 of x, let's say, just as an example here, we know that this graph will continue to go all the way down to -infinity. It's going to keep getting closer and closer and closer to the y-axis, but it's never going to touch it. So based upon what I'm seeing on the graph here, we can see that the range is going from -infinity to positive infinity, while our domain here is going to start at 0 but not included, and then head out to positive infinity. Okay, more about those ideas in the next part of this. Make sure that you understand that whole idea of the fact that that graph does not touch the y-axis but keeps on getting closer and closer to it.